Let's talk about how you can check your work for imaginary and complex numbers by using a graphing calculator. First, if you take the square root of -16, you get error. It's a non-real answer, and that's because it's imaginary. But we can set the mode to answer in complex, not just an error. We can go to modes and set this to be a plus bi. So now when we enter this in again, we get 4i. When you set this up, I was at first worried if for a real answer it would have real plus 0i, and that would be a little bit annoying. However, fortunately, if you just have 2 plus 3, it gets 5 and not 5 plus 0i. So it's probably just easiest to set it up in the mode as a plus bi, and so you don't have to switch back and forth. Let's talk about how you can use the graphing calculator to check your work on some problems involving the complex numbers. Let's talk about the first case, where you're adding or subtracting complex numbers. So I'll put parentheses around the first one. You do not have to put parentheses around the first complex number if you don't want to. The calculator will already go from left to right because it's adding and subtracting, and PEMDAS has it so that adding and subtracting go from left to right in the calculator-based PEMDAS. Now you subtract. Now you do need to have parentheses around this because you're subtracting the whole expression of 3 minus 6i, the whole complex number. And then you can press enter, and you get the same answer that we had here, and so we checked our work. Let's now talk about how to check this problem by using a graphing calculator. Press 5, enter in I, raise it to the 17th power, and press enter. Now wait a minute, this looks a lot different than what we have here. Why is that? Well, you notice that the real component here, the part that's different from this answer, is really small. It is 1.5 times 10 to the negative 12. So really small and close to 0. And that is what we have for the real component here is 0. Now why did the real component here not be 0 exactly? Why did it give a number other than 0? This is due to calculator error. And the imaginary part is 5i, and the imaginary part here is 5i. And so we check to work by checking both the real components and the imaginary components. Let's now talk about how to solve this problem. Enter in the first complex number. Put parentheses around it. Multiply it by the second complex number and put parentheses around it. Press enter. And you note that the complex number here in the calculator and here in the answer is the same, and so we check to work. Let's talk about how to check your work by using a graphing calculator for this problem. Enter in the first complex number and put parentheses around it. Press the divide sign and enter in the second complex number and put parentheses around it. Press enter. Now the calculator gave the real and the imaginary parts in a decimal format, while we gave them in a fraction format for both the real and imaginary parts. So what should I do? There are a couple or so ways of checking your work here. You could press math and then choose option 1, and this puts the answer the calculator spat out into the fraction format. And you can easily check that the complex numbers here and here are the same. You could also do this by the real and imaginary parts separately. So let's enter in the real part first, press math, choose option 1, and this matches with the real part here. Now let's enter in the imaginary part, press math and choose option 1, and that matches with the imaginary part here without the I. Now there's another way you could do this, is that you could enter in the real part here, and you see that matches with the real part the calculator spat out, and then you could enter in the imaginary part here without the I, and you would see that it matches what the calculator spat out here. And so whatever way you choose to do after the calculator spat out this answer, either way we checked our work. Let's now talk about how to check this problem by using a graphing calculator. Press math, choose a tab number, choose option 1, absolute value. Enter in the complex number you want to take the absolute value of. Press enter. Now the calculator gives a decimal approximation and not the exact answer. So how would we check our work when we gave the exact answer here? we'll enter in this into the graphing calculator. Now, a decimal approximation for that is the same as a decimal approximation of what the calculator originally spat out, and so we checked our work.
Here's a link to the playlist in which this video is a part of. It includes other similar videos about how to check your work using a graphing calculator.